All right, so we have closure on the system that we've installed. So this is where the intermatic used to be, and this is the digital timer that we installed, and it siphons power from the big box right here. And also inside the conduit is a signal line that kind of runs down here to this pump relay control. So now this device controls this device, which allows power to go to the pump and then activate the irrigation system. So this is how you would modify an existing pump system into a digitally enabled system. All right, everybody, welcome back. Today we have another very exciting episode for you. So what we're looking at today is a 220 pump that powers the irrigation system. And over here, this is the trusty intermatic timer, that a lot of people have. So I found a lot of people have asked me how you can convert this into a web-enabled digital system. And so that's what we're doing today. We're going to be installing a low voltage controller and displacing this 220 analog timer. Now the first step in working on something like this is to cut off the power feeding the timer and the pump. So we're going to go in here into the main box. This is where the power comes in from the power company. And once my tools get here, I'm going to open this and see which rail it's drawing power from and kill it. So we're opening this just to evaluate the circuitry. So the line goes from here. We have a white line that's power and a black line that's power. So this is the sprinkler. It should kill all the power going to it. And 220, ground is not connected. We'll fix that when we're done. I don't know if you heard all that, but this is one hot leg, the other hot leg, because the ground that's not connected. We'll fix it when we're tidying things up. So that should be power free now. So before we go, we killed the power, so it's safe to work. But before we start disconnecting things, what I like to do is kind of anticipate what we're doing. So since we're going to have to mount the low voltage components like the 120 controller and the contactor switch, I'm going to try and mount those physically first before I start cutting cable. So let me elaborate real quick what we're doing. So this is a controller. This is a timer for the for sprinkler systems that uses city water. And what happens is those irrigation systems are usually controlled by a low voltage valve. By low voltage, I mean like 24 volt alternating current. And you have city water feeding the system, and you just have this controller through these pins right here that'll send 24 volt AC voltage to the valve, which will open the solenoid and allow the water to flow. And that is not how our system works. So our system here is actually powered by 220. So whenever the timer hits a certain gear, it'll allow electricity to flow through to the pump, and the pump will activate. And the different zones are controlled by what's called an index valve. It's that green thing right here. So what we're going to have to do is we're going to have to be creative here. We know that this thing can control the timing, and it'll send a 24 volt signal, right? So we have to use this, and then I'm going to have another weather box like this. Also Orbit, I'm not sponsored by them, it's just that's what they have at the stores. And we're going to install something like this. This is called a contactor. So you would typically find this in an air conditioner. And how this works is there's a magnetic switch, a solenoid switch, that receives 24 volt AC current, voltage and current. And what happens is you have a line side on one end and a load side on the other. And whenever the timer decides that, hey, I want to start the sprinkler system, it'll send the 24 volts into this coil and it'll engage the switch, which is in essence kind of like how the intermatic does the switching process mechanically, whereas we're gonna change it to electromechanically. And yeah, I hope that didn't complicate things anymore. All right, maybe once I install it, it'll be more self-explanatory. Okay, this is a update to the documentary. So we try to use a pump start relay, a home rig one for air conditioning, and it didn't work. So what we ended up doing was we had to get one of these solid state ones ready made for this purpose. So the 24 volts come in through the top, and there's a line 1, line 2 in, line 1, line 2 out, and that's where it runs out to the pump. And this one works much better than our home rig contraption. So I'm going to close it up now. All right, we've had to make a couple modifications to the design. So this is where the controller is. The controller is going to draw power from this existing conduit. We pulled two new lines. One will be for power, and the other one would be for the 24 low voltage signal. Now all we have are our number 14 wires, so that's why we're doing this. So power is going to come in from the conduit, from the main box, and it's going to feed the controller. The controller then is going to send a 24 volt signal back into this box, back into one of the two lines, back in here. All right, once it comes back, one line will be hooked to the mains power. The other line will be hooked to these two black and white lines. That goes straight to the pump relay. So, you know, once I get the labeler, I'm going to label all these. This will be low voltage, well, 24 volt AC, and one of these two lines will be 110, 120, and one of them will be 24. All right, that's why it looks kind of odd right now.